Hello, my name is Dr. Rhiannon Hall. I'm a lecturer from the Maths department at Brunel University, and I'll be giving you a brief whirlwind tour of the courses that we offer at Brunel University in the Maths department. So you can see on the slide the main courses we offer are the mathematics, the financial maths, the maths with computer science, and the maths and stats with management. We offer these all as a Bachelor of Science, and we also offer the mathematics and the financial mathematics as an M-Math, which is an integrated master's degree. So what that means is you'll study the same material for the first 3 years that the people on the Bachelor of Science degree do, but then you'll do 1 year after that at master's level, studying in the classroom with master's students. So you may be asking, well, what's the difference between an M-Math and a traditional master's degree, a postgraduate master's degree? Well, what happens is you'll be in the classroom with the students, the master's students, during the year, studying with them, and you'll take your exams in May with them, and then you'll graduate after those exams. But the students on the traditional postgraduate master's degree will then go on and do a research project over the summer, which you won't do. So that's the difference between an undergraduate master's course and a postgraduate master's course. You'll see also on the list of bullet points, the 5th bullet point is the integrated foundation year. We also offer some integrated foundation year programs, and I'll talk to you about them on the next slide. I'd just like to draw your attention to the bullet point at the bottom of this slide, which is that we offer a 1-year work placement, and this is available for all of our courses. You can take a 1-year work placement regardless of which of our courses you do. So for all of our Bachelor of Science courses, our entry requirements are BBB, and for our undergraduate master's programs, the entry requirements are ABB with an A in Maths. Okay, so now I'll talk about our integrated foundation program. What this is a pre-degree year for those of you who are not fully qualified to start on the degree course. So it's 1 year full-time study, like the kind of full-time study you would do on a normal degree, but it's pre-degree. So, and what it does is it offers you, if you pass and you meet the progression criteria, then you will automatically progress onto certain degree courses offered at Brunel. So the Maths and Computing with Integrated Foundation year. If you take the Maths route, then you can progress onto any of the Maths courses offered by Brunel. If you take the Computing route, you can progress onto any of the Business Computing courses and any of the Computer Science courses. And for the Economics and Maths Integrated Foundation year, you can progress onto all degree courses in Economics and Finance. So the entry requirements for the foundation year are CDD, and if you're aiming to study the Economics and Maths one, then preferably you would have Maths or Economics or Politics at A level. There are bursaries being planned, but the details haven't yet been finalised, so please watch the web pages for that. Okay, so onto the degree courses. One of the big questions people ask is, what will I study? So in year 1, you'll build on the familiar kinds of mathematics that you've seen before, but you'll build them up further and more advanced. So calculus, algebra, probability, things like that. In addition, we like to do some maths applied to the real world. So we have these applied maths projects that our students do. One of the projects is in modelling student loans, and the other project is on the Google PageRank algorithm. In addition to that, in year 1, for the core maths modules, we teach all of our students in small groups for the first few weeks of the year. And this is to help you transition between the school environment and the university environment. So in the small groups, we simulate what's familiar from school, and then after a few weeks we transition to the traditional lecture style teaching, which is traditional at universities. Right, in year 2, the maths becomes more advanced, the applications to the real world become more advanced, and you'll meet some topics that are quite unfamiliar to you at this stage. For example, multivariable calculus, group theory and analysis. For those of you who want to study specialisms other than maths, so if you're taking, for example, the financial maths degree, there'll be some investment maths. The maths and statistics with management, there'll be some management and accounting. And the maths with computer science, there'll be some software development. And then in the third year, one of the major components of the third year is the final year project. So this is 1/3 of the final year, so it's a major project where you look very in-depth at a particular area of maths, a particular subject. Quite often it will be an application of maths to the real world. In addition to the final year project, you'll do modules in a number of quite advanced mathematics topics, and these are just a few examples: coding and encryption, complex analysis, and so on. Year 4 is for the students who are doing the undergraduate masters. This is the masters level year. There'll be extended project work, some advanced maths and material on finance or analytics, and advanced use of computers. So we'll just go a little more in depth, mainly about what happens in the first year. But if you look at the right-hand side of this slide, a question people often ask is, how much time do we spend in our core maths subjects and how much time on our other specialisms? So in the first year, there are 6 modules. 5 of those modules are core maths modules that everybody takes. And one of those modules is a module that you take that's specific to your other specialism. But then the ratio changes in year 2 and year 3. So in year 2 and year 3, it's 2/3 core maths and 1/3 your other specialism. So if you go to the left-hand side of the screen now, the core maths in year 1, these are the main topics that are studied in the core maths classes. So there's transition classes, which I mentioned earlier. There's familiar things like calculus, algebra fundamentals, algorithms and computing projects. This is where we get you using some mathematical software to program algorithms, program some computational stuff, some loops and things, and to work through your projects. So the mathematical software we use is something called MATLAB. There's also probability and statistics and essential skills. Down the bottom are the modules that students will be studying for their other specialisms. So the first bullet point, programming, is for students on the Maths with Computer Science course. Organisational behaviour and analysis is a management course, so that's for the students who are studying maths and statistics with management. And the students studying the straight maths course or the financial maths course will be doing a module on applied maths, including some finance topics. Okay, so I'd like to talk about careers and employability, because we really like for you to come to university, but we want you to leave and to have a lot of employability skills so you can go out into the real world and perform well on the job and apply what you've learnt here to the real world. So we run these employability days, we call them. The first one, the training day, we run that in year 1, and that lasts a whole day, so we cancel the classes for the day, and we get all our year 1 students into a great big room, and we look at CV writing, job application forms and cover letters. Then in year 2, in the autumn term, we have something called an assessment day. Again, we cancel all the classes for the day and we get students together. They look at mock interviews, role play, psychometric tests and networking skills. And then we have our careers day. That's also in year 2, but that's in the spring term, and this is where we invite a number of alumni and employers to come in and give talks to our students. So our students receive a lot of advice about the various career directions they might go in. We also have a lot of Q&A sessions on career options. Okay, so on the topic of employment, there's a very modern area of employment that's been emerging, data. You'll see a lot of new courses popping up in data science and analytics. So the question is, well, what is data? Is it maths? So you'll see there's loads and loads of different types of data. We can just pick out a few here. For example, personal data being things like your name, address, email address. There can be sensitive data like your genetic material, behavioural data, so your search history, for example, societal data like crime statistics or medical statistics. And there's just a whole range of data out there. So what is data? Well, data is information, and it can be in any form from any source, and we are generating it all the time. Look at that, it's your phone. Every time you pick up your phone, you are generating more data. And every time you swipe a club card at a shop or something, again, you're generating more data. Right, so clearly data science it's an emerging new area, and there's a huge growth in jobs. So in the UK, the growth in the number of jobs in advanced data, looking at the top for the total for the UK, back in 2013, just over 8,000 jobs. And more recently, 5 years later, that's grown to just over 27,000 jobs across the UK. And if you want to focus in on London, which is this area of the country, back in 2013 there were just over 4,000 jobs, and after 5 years that had grown to just over 14,000 jobs. So data is really huge, and you'll see a lot of new courses popping up in data science and analytics across the country. And Brunel Maths, we're in on this game. We know that it's big, we know that it's important, and we have a new degree course coming soon, so watch this space. Okay, so we've mentioned earlier that every one of our courses offers the possibility for a work placement. So you have the option of taking a work placement. So you might be asking yourself, well, should I do a work placement? Well, here are some reasons that you should consider. You'll get valuable work experience. You'll get a taste of a potential career path because you'll be out working in industry for a whole year. And you'll improve your final year results. So students that come back from their work placement, they tend to have improved time management skills, improved discipline, and things like this. So the work placement, it comes after your second year of study. So you do 2 years of study, then you go out on your work placement, then you come back for your third year and your fourth year if you're doing an undergraduate master's. There is a modest assessment involved in the work placement, but it is really modest. It's just where you need to talk and write about what you've done out on work placement, which is relatively easy because you're talking about what you do every day out at work. And you'll earn some money. So we've got some recent statistics from 2017-2018. The average starting placement salary was just over £18,000. Now, if you look at the bottom of this slide, the fees, the university fees for the placement year, it's £1,000 for the year you're out on placement. So if you subtract that from the money that you earn, that's £17,000, that's before tax. Right, and on top of that, it's not just about earning money for 1 year while you're studying. When you graduate, you'll earn more as well. So again, recent figures on Brunel Maths graduates. So the starting salary when they graduate, on average, it's 25,800 for students that had done a placement, whereas it was 23,600 for students that had not done a placement. Right, so you'll ask the question, are maths graduates employable? Well, we've just talked about your starting salary. Let's have a think about your salary 5 years after graduating. Here's a study that was done by the Institute for Fiscal Studies. This was published on the BBC News website in November 2017. And it shows the average earnings of graduates 5 years after graduating. And there's no surprises that medicine and dentistry are the highest earners. But if you look at the third from highest earners, this is mathematics. These are students graduating with mathematics degrees, and they are earning the third highest salaries of the graduates of the, and they are earning the third highest salaries of graduates across the various disciplines that are traditionally taught in universities. So what kind of jobs do maths graduates do? Here's just a list of a few job titles that a few of our recent graduates have. In particular, one thing you'll notice is that you won't see a job advert for a mathematician wanted. Job adverts are for job titles like these. But the word that you see quite often is analyst. And this is not surprising because as a mathematician you'll have developed a lot of analytical and numerical skills. So it's these analytical and numerical skills that are in high demand. Right, so I'd just like to reiterate our entry requirements and our fees. For the Bachelor of Science courses we require A levels at BBB and the course fees are $9,250 per year. For the undergraduate master's courses, our entry requirements are ABB with an A in maths, and the fees are £9,250 per year. But in the master's year, so that's the fourth year, we offer a £2,920 discount. That's for students starting in September 2020. Now for the foundation year, our entry requirements are A levels at CDD, and the course fees are $9,250. And if you choose to do a work placement, then the course fees are £1,000 for that year. In addition to the A levels, all our students must have 5 GCSEs at grade C or higher, and that includes English and maths. So thank you for listening. If you have any questions, please contact us.